Good morning, class. Today we will be proving lines are parallel. The main focus of this one is that we will be able to determine if lines are parallel using limited information. Just like the last two sections, we will still be dealing with corresponding, alternate interior, alternate exterior, and consecutive interior angles. All these are vital in showing that two lines are parallel. In fact, the goal of today will be learning the four converses of the postulates and theorems that we learned in section 2. So you will learn how the angles formed by a transversal can be used to determine that lines are parallel. You should also be able to justify why lines are parallel by looking. The first one is the corresponding angles converse postulate. If you remember the corresponding angles postulate, it said if two lines are parallel and cut by a transversal, then, well, if it's the converse, that if part, if two parallel lines are cut by a transversal. So the condition that needs to be met there is parallel lines. So that parallel lines is going to be moving to the then part of my converse. Alright, back to the original. Then corresponding angles are congruent. So that corresponding angles being congruent has to move into the if. But we still have to phrase it such that it makes sense. So I still need if two lines are cut by a transversal. I just need two lines cut by a transversal. If that doesn't happen, I can't do the corresponding angles converse postulate. And I need the pairs of corresponding angles to be congruent. All I need is really one, but if I had all four, awesome. Then I know the lines are parallel. So in this case here, angle 1 being congruent to angle 5, well, angle 1 and angle 5 are corresponding. Or angle 2 and angle 6, or angle 3 and angle 7, or angle 4 and angle 8. Any of those pairs would have been enough to now say line N and line P are parallel. I put the symbol in here to show you. So again, I went from not being parallel and knowing that these are congruent to saying, hey, I know these are congruent. Those forces line N and P to be parallel. Okay? Again, this one's the postulate. I can't prove to you why this happens, but it does. Alternate interior angles converse theorem. Again, we're reversing the flow here, so if I know alternate interior angles are congruent, then I know the lines are parallel. So if I know angle 3 and 6 are congruent, or I know that angle 4 and angle 5 are congruent, I now can say line N and P are parallel. Okay, I used the red markings to show it. I didn't write it out, but I could say line N and line P are parallel. Alternate exterior angles converse theorem. Again, if I know alternate exterior angles are congruent, then I know the lines are parallel. There we go. And the last one, the consecutive interior angles converse theorem. If two lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So if I have the consecutive interior angles being supplementary, then I know the lines are parallel. So if angle 3 and angle 5 are supplementary, or angle 4 and angle 5 being angle 4 and angle 6 being supplementary, then I know that this is parallel. So again, all four of these, all they tell you is if or whether or not these lines are parallel. That's it. One important thing to note is that you can label these similarly to the last one, the CAC postulate, corresponding angles converse postulate, the alternate interior angles converse postulate, AIAC postulate, theorem, alternate exterior angles converse theorem, AEAC theorem, and then the CIAC theorem is the consecutive interior angles converse. I know that it can get to be an alphabet soup a little bit here with all this. You just have to remember their names, consecutive interior angles converse. I would strongly recommend not using the abbreviation until you've gotten past chapter 3. We will be using these. You need to know them. They are building blocks. The last one is the transitive property. This is, again, just something that shows up. There's the transitive property of equality. There's the transitive property of congruence. There's the transitive property of parallel lines. Basically, if two things are congruent, equal, or parallel to the third thing, then they have to be congruent, equal, or parallel to each other. So if I have two things being parallel to the same line, they have to be parallel to each other. So in this case, I have line M and line N being parallel based on these markings, and I have line N and line P being parallel based on these markings. Well, that should mean line M and line P should also be parallel. And that's what the transitive property says. If I have these two sets being parallel, both being parallel to N, then they have to be parallel to each other. There's one important thing that you really need to note here. There is no such thing as transitive property of perpendicular lines. If two lines are perpendicular to one line, they are not perpendicular to each other. This transitive property is selective. Equal, congruence, or parallel lines. That's it. Done. Okay? Alright, at this point you should be able to identify the special properties of the four new angle pairs that we've talked about, the corresponding angles, alternate interior, alternate exterior, and consecutive interior angles. If you know corresponding angles, alternate interior angles, or alternate exterior angles are congruent, you know two lines have to be parallel. If you know the consecutive interior angles are supplementary, you know two lines that have to be parallel. And you should know the transitive property of parallel lines. Well, till next time.